Section 5.3 is on interpreting and sketching graphs, and many of the graphs we've seen so far in this chapter have been linear graphs, and we'll talk a little bit more about the qualities of linear graphs later in the chapter. The big thing about linear graphs, so they're straight lines. But right now we're going to talk about just graphs in general, and a lot of times when you have data, you can represent the information using a graph. And typically whatever the vertical axis represents and whatever the horizontal axis represents help to tell you what the graph itself is about. So let's look at a couple of examples here now, just to show you how you can represent and read the information graphically. So the graphs that we're going to be looking at are going to be mostly composed of different line segments. And when you look at the graphs, for example, the one that's here below, you'll see that the steepness of the line changes, and that has some significance to the meaning of the graph. This particular graph, the vertical axis represents distance in kilometers, and the horizontal axis represents time in minutes. So when we look at each of the line segments, they are indicating a change in distance as the line goes up or down over a change in time. So when we look at that relationship, you should know from science that when you're looking at a ratio of distance over time, then that would represent speed. So for example, in this particular graph, segment AB, if you go from point A to point B, you have traveled a distance of 1 kilometer, because point A's distance coordinate is 0 kilometers and point B's distance coordinate is 1 kilometer. So you would have traveled 1 kilometer distance, and the time it took you to get from point A to point B is you'll be looking at the time coordinate, which in this case would be 0 for A and 30 for B, so that would be 30 minutes. And that would be 1 over 30 kilometers per minute. Which is approximately 1 divided by 30 is approximately 0.033. Kilometers a minute. Now if you wanted to, you could write 1 kilometer, and this one here is pretty easy to change to kilometers per hour. We will learn how to use conversion factors to change units later on in the course, but right now this one is not too hard to show you, so I'll show you that. If you have 30 minutes, if you just multiply 30 minutes by 2, you'll get 60 minutes, which is an hour. So whatever you do to the bottom, you have to do to the top, so that you're really like multiplying by 1. So this becomes 2 kilometers over 60 minutes, which is 2 kilometers per hour. So either of these answers would be okay. This one here in kilometers per minute, or this one here in kilometers per hour, they mean the same thing. Okay, so if we look at some questions now related to this particular graph, it asks you to calculate the speeds during the intervals from BC, intervals BC and DE. And if we look at BC from point B, which has a height of 1 kilometer on the vertical axis, and C is at a height of 9 kilometers, so that would be a change in distance of 8 kilometers traveled, 9 take away 1, and the time from B to C would be from 30 minutes up to 40 minutes, so that would be 10 minutes. Which equals 0.8 over 10 is 0.8 kilometers per minute. And this one wouldn't be too hard to change to kilometers per hour either, because you could multiply the 10 minutes by 6, and whatever you do to the bottom you have to do to the top, so it would be 8 by 6, so 48 kilometers in 60 minutes or 48 kilometers an hour. DE, if you look at D's height, was 9 kilometers, and E's height, go across, was at 6 kilometers, so therefore there's 3 kilometer difference there between those. And from D to E, at D is 55 minutes, and E is 95 minutes, so that would be a difference of 95 minus 55, or 40 minutes. And you don't usually say 3 over 40 kilometers per minute, you'd usually change that to a decimal, which would be 0.075 if you take 3 divided by 40, and that would be kilometers per minute. That one would be a little bit harder to change to 60 minutes, but again, we will learn conversion factors later on in the course. So right now it's okay to leave it as kilometers per minute. It doesn't specify kilometers per hour. So the next question asks us to look at what's happening from in the interval from C to D. And if you look at what's happening, there's no change in the distance. So no change in the distance as time passes would imply that you're stopped. And question C says, what segments show the distance from the starting point is increasing? So if we look at the graph again, we've got some segments that are rising as time goes on and some segments that are falling as time goes on. So the ones that are rising would of course mean that the distance is increasing. Increasing would be segments AB and BC. And decreasing would be the ones where the line is falling as time moves on, and that would be segments DE, EF, and FG. And the next question asks you, can you deduce where the biker was at the end of his journey? At the end of his journey, he's back to, if you look at point G, the kilometers are back to 0 again. So this would mean that he or she, so the hiker or the biker is back at the starting point. Since the distance is 0 again. Okay. So looking at the graph now, just to go back to the steepness of the lines, there's no question here about that, but you should notice that when they have the steeper lines, for example BC, that would mean that there's a greater change in distance over a smaller change in time, which would mean that the speed would be greater. And you can see from some of our calculations there that BC had a speed, if we look back at question A, BC had a speed of 0.8 kilometers per minute, and DE had a speed of 0.075 kilometers per minute, and BC obviously is much steeper than DE. So you can see that the speed is much higher. Okay, the next question is a graph about the distance that Heidi is from her starting point while jogging around Quidi Vidi Lake. Describe what Heidi could possibly be doing at each of the intervals. So we're going to take each segment down here and fill in the blanks and try to come up with a description when we look at it of what's going on. So the first question you're asked or asked part, the blank to fill in is talking about segment AB. And it says, since the distance is increasing, you can see from point A to point B, you're increasing, your distance is increasing. That would indicate that the jogger is moving away from the starting point. And her speed would be the change in distance from point A to point B is 0 up to 100, so 100 meters in this case, over from point A to point B, the change in times, which is on the the horizontal axis, goes from 0 to 15, so it'd be 100 meters divided by 15 minutes, which would be 100 divided by 15 would be about so approximately 6.7 meters per minute. So then if we look at the next segment, BC, you can see that this line is steeper. So a steeper line would indicate that she's moving at a faster rate, because the distance that you're moving a greater distance over a shorter period of time, so that would indicate a faster speed, distance over time. So her speed at the particular speed at segment BC would be from a height of B of 100 meters up to C is 600 meters, so that would be a difference of 500 meters covered, over the time frame from B to C would be from 15 minutes up to 30 minutes, so that would be a difference of 15 minutes, and 500 divided by 15 would be approximately 33.3 meters per minute. So now if we look at sections CD and DE, section CD, since the distance is decreasing this time, you can see that going from point C, you're moving down to point D. So the distance is decreasing, which means the jogger is moving back toward the starting point again. And the speed from C to D, you're at C you're at a height of 600 meters, D you're at a height of 500 meters, which means 100 meter difference between those two points. And from C to D, C is at 30 minutes, D is at 35 minutes, so that's only a 5-minute interval. So 100 divided by 5, or 20 meters per minute. Section DE on the graph indicates that the distance is not changing, because it's a horizontal line, there's no change in the distance, so therefore the jogger has likely stopped. And then segment EF, the change in direction indicates that the distance is increasing again, so that means the jogger is moving away from the starting point again. And the speed for EF, forgot to scroll that down again to see, from E to F goes from 500 up to F's point is at a height of 800, so 500 to 800 would be 300 meters, and from E to F would be 50 minutes up to 60 minutes, so 300 meters in 10 minutes. So speed of 300 meters in 10 minutes, or that would be exactly 300 divided by 10 would be 30 meters per minute. So if we go back again and look at segment FG, the distance is decreasing again, and the question we're being asked, So since the line is, in this case, falling, the distance is decreasing, and the jogger is moving toward the starting point. So back toward the starting point, and the speed, I have to go back up to the graph again. The speed, you're gone, point F is at a height of 800 meters, point G is at a height, we look at G's coordinates, oops, G is at a height of 300, so that's a change in distance of 500 meters, and the X of, or time coordinate for F is 60 minutes, time coordinate for G is 90, so that's 30-minute difference there. So from 800 to 300 was 500 meters over 30 minutes, right? So we go back down, 500 meters over 30 minutes, which is approximately 500 divided by 30, but check that, is approximately 16.7. meters per minute. Squeeze that in there, sorry. So in segment GH, if I go back and look at the diagram again, segment GH, again it looks like there's no change in distance, so that means they've stopped again. So GH indicates that the jogger has likely stopped. And the last segment, HI, the distance is decreasing to 0. The steepness of the line indicates that the jogger is moving at a faster rate. If we just go back and look at the diagram once more, it's a steep line, so it's a faster rate. And you're covering from 300 down to 0, so 300 meters in a time span of 95 to 100 minutes, so 300 meters in 5 minutes. So it's at a faster rate, and her speed is 300 minutes. 300 meters, I'm sorry. .300 meters over 5 minutes, which is 60 meters per minute. So we just take one moment, just one more, just go back and look at the whole graph. We've talked about it in little bits and pieces, but if we kind of look at it now and look at a kind of a description of what happened, you can see that the jogger left the starting point traveling at segment AB at a fairly low rate, and then sped up a little bit, jogged a little faster, then turned around and went back and stopped for a little while, so maybe the jogger dropped something and realized it, turned around and went back to pick it up, then started again, moving forward again till it got to about an hour into the run, and then just turned around and started heading back towards, or actually I guess at that point, if it's Kittyville Lake, they've reached the kind of halfway point and have started on their way back to their starting point again. But at 90 minutes into their jog, they stopped again, the person stopped again for 5 minutes, and then speeded up, or sprinted I guess, to the end, and finished. It took 100 minutes to finish the run. So our next question now has another distance time graph again. So again, the steepness of the line segments would indicate speed. The steeper the line, the faster the speed. And line segments that are rising would be line segments where the distance is increasing, and line segments that are falling as we move to the right would be indicating that they're returning to their starting point. So let's answer some of the questions that are asked here now about Little Red Riding Hood's route, and it's the journey taken by Little Red Riding Hood on her motor scooter from her home to her grandma's house. Okay, so how long did her journey take in total? If you look along the horizontal axis, you see that it started at 0 and continued to move along the route and to get to Grandma's house, and then came back, and it took a total of, to get back to distance 0 again, it took a total of 110 minutes. Where was she at the end of her travels? Well, her distance was at 0 again, so she was back at home. At what time did she reach her Grandma's house? So if we look at the time along the horizontal axis, it appears that the time where she had the longest stop is associated with 50 minutes. And the stops again are indicated, in this particular case, are indicated by horizontal lines, because that horizontal lines in this case indicate the distance hasn't changed as time moves on. So it looks like she reached her Grandma's house at 50 minutes. How far away from home is Grandma's house? And if you look at the vertical axis to figure out what coordinate goes with that particular time, it's 18 kilometers. How long did she stay at her Grandma's house? The horizontal line starts at 50 minutes and stops at 70 minutes, so that's a difference of 20 minutes. How many times did she stop on her journey? And again, horizontal line segments would indicate stops because the distance isn't changing as time moves on. So that's one. There's one here, one here. Whoops, gone up a little bit too high there, sorry. One here, and one here, so total of 5. And what was Riding Hood's speed between 30 and 50 minutes? So from 30 to 50 minutes, 30 has a height of 8 kilometers. 50 has a height of 18 kilometers, so that would be 10 kilometers. And the time from 30 to 50 is 20 minutes. So that would be 0.5 kilometers per minute. When was she traveling at the fastest speed? Next question. So we look to see where she was traveling at the fastest speed. That would be the steepest line. And just looking at eyeballing it, it looks like the fastest speed might be here from 95 to 100 minutes. So if we look at the kilometers before we move down, 95 to 100 minutes. 95 was at a height of 12 kilometers, and 100 minutes is at a height of 4 kilometers. So that would be, what did I say, 12 to 4, so that's 8 kilometers. Oh, it's asking when, sorry, when was she traveling at the fastest speed? I would say 95 to 100 minutes. And then determine the speed of your answer. Okay, there's where we want to express the speed. So we said from 95 to 100. If you look back at the graph again, it traveled from 12 kilometers down to 4 kilometers, so a distance of 8 kilometers in 5 minutes. So 8 kilometers in 5 minutes. So it would be 8 kilometers in 5 minutes. Now this one wouldn't be too hard to change kilometers per hour, because 5 minutes, if you multiply that by 12, you will get 60 minutes. So that would be times 12, which would be 96 kilometers over 60 minutes. Which is the same thing as 96 kilometers an hour. And next question is, during the first half of her journey, the segments are mostly rising, whereas the segments for the second half are mostly falling. What does this mean? If we just look back again for a moment. The rising parts indicate that the distance is increasing, whereas the segments that are falling indicate that the distance is decreasing. So in terms of our graph, that would mean that those that are segments that are mostly rising would mean she's on her way to her grandma's, whereas those who are falling mean she's on her way back home. So the rising segments would imply on the way to grandma's house. Because the distance is increasing for those segments. And the falling segments would indicate that she's on her way back home. Because the distance is decreasing and the segments are falling. As time goes on, the distance is decreasing. Okay. Example, get you to draw a graph. And this one is a little bit different because this time they're asking you to look at the situation that's being described is at the beginning of the race, Alicia took 2 seconds to reach a speed of 8 meters per second. She ran for 12 seconds, then slowed down to a stop in 2 seconds. And you're asked to sketch a graph of speed, not distance, but speed as a function of time. So that means that speed is going to be your dependent variable, and time is going to be your independent. And that just kind of tells us which axis to put which quantity on. Because the independent generally goes on the horizontal axis and the dependent generally goes on the vertical axis. So I'm just going to move the graph up just a little bit. Right, so this would be time, and the units for that would be seconds. And this one, the speed, would be on the vertical axis, and it's in meters per second. And if we look at the times that are involved in this particular situation, they said at the beginning of the race it took her 2 seconds, so that means she got 2 seconds to reach a speed of 8. Then she ran for 12 seconds, so 2 plus 12 would be 14 seconds, and then she slowed down to a stop in another 2 seconds, so another 2 seconds on to 14 would be 16 seconds. So we need to have at least 16 seconds along our horizontal axis. So if we look at, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so probably go in units of 2. So 2, 4, 6, 8, 10, 12, 14, 16. And then the speeds, it says, well, obviously she started at a speed of 0, but then she reached the speed of 8, ran at that speed for a while, and then slowed down. So we need to go at least as high as 8. So 2, 4, 6, 8, we can probably do it units of 1, every block representing a unit. So I'm just going to label every second one. So 2 meters per second, 4 meters per second, 6 meters per second, 8 meters per second on the vertical axis. So if we draw our sketch now for this, sketch our graph for this particular race, started off at 0 meters per second at the beginning of the race, took 2 seconds to reach a speed of 8. So you draw a line from 0 to 2. Should be a little bit straighter than that, but that's the best I can do, sorry. And then she ran for 12 seconds. So 12 seconds. You wouldn't stop at 12 because you're at 2 right now. So 12 more would be up to 14. So up to 14 would be a straight line there. And I'd be using a ruler if I was doing this on paper. Okay, and then she slowed down to a stop in 2 seconds. So it took her another 2 seconds. So she would reach basically a speed of 0. That's not a real good line there, so I'm just going to try that one once more. Very hard to do this with these pens. Okay, so this would be a rough sketch, a very rough sketch of your graph. If you're doing it on your own paper, obviously you'd be able to use a ruler and probably have a steadier hand with a pencil than I have with this pen on this iPad. Okay, so that's basically the graph, and you can probably, if you want, just call it Alicia's race. All right. So if you look down at the end here, there's some questions you can try now. In the textbook on pages 281 to 283, those questions are some practice questions you can try to help you with this section.